Hello and welcome to Intro to C++ Programming. This is another video that's going to be about terminology. It'll have some pseudocode in it. If you want to just go right into the coding, I would recommend skipping this video. If not, welcome, and without further ado, let's get started. So what we're going to be covering in this particular video is terminology of different concepts and ideas in programming in general, paradigms, discussing the differences between different languages, and languages themselves. So ones that you're going to most commonly see among programmers and what each language is used or does best. It's certainly not a comprehensive thing for languages. Again, there's a lot, but these ones are really widely used and they have pretty good support. So what we're going to be covering first is terminology. So different terms are used across all languages, as well as what programming actually is. So what programming actually is the process of designing and building an executable program to complete a certain task. So within programming, tasks may involve analysis, creating a algorithm and or data structure, assessing its accuracy and resource consumption, implementing them, debugging them, and then executing them as one complete program. So quality requirements of a program. So you want reliability, which is how often it's going to be correct, robustness, how well it's going to anticipate errors, usability, how easy the program is for a user in terms of its intended purpose, portability, how many operating systems or platforms a program can be compiled and or run on, maintainability, how easy it is to modify a program for later improvement or customization, and efficiency, how much time or space a program takes up. Now, considering this isn't a system analysis course, we're not really going to get into it, but these are just things to keep in mind when you're making a program. Maybe that isn't necessary for like a simple hello world, but when you get more into it, this is definitely really important. So, readability of a program, also extremely important. So, it factors in your own style of programming, which you'll gain as you get more competent. Factors will include white space or indentation or new lines, comments, decomposition or breaking apart or method down into smaller pieces, and naming conventions. So if you're using an IDE, which we'll talk about later, some of this will be handled for you, namely the indentation and sometimes the naming conventions. If the naming conventions part isn't handled automatically, you can add like a plugin for that, but I personally prefer just naming everything myself. So programming languages. So a programming language is a vocabulary and set of grammar rules for instructions meant to perform a task. So programming languages are meant to be a readable set of instructions to give to the computer versus machine code actually used by the machine. So we'll talk about it a little more later, but machine code is like the actual like ones and zeros, the binary. You don't write that. That's insane. Programming languages are meant to be readable for the user. There's some in-between steps that we'll show off later, but we're going to be focusing more on C++ is considered like a mid-level, but it's readable. It's for people. It's what I'm trying to get at. This is usually in references to high-level languages. Again, there's stuff that's like really low-level, and that has to do directly with the machine. This is not going to go over that because it is awful to set up, but basic functions of any given programming language. So there's the input, which will grab the data from some kind of input device, file, so on and so forth. Output, which is going to display data on the screen or just somewhere, and it'll send data elsewhere. Arithmetic, which is math, and it'll perform basic, subtraction, addition, multiplication, division, and remainders. Conditionals, which will check a certain condition and execute the appropriate statements, and repetition, which will perform an action repeatedly, usually with some kind of variation each time. There's obviously more, but this is like stuff that's built into the language, and every language has this, no matter what it is. So, Integrated Development Engine, or IDE. You saw this word earlier, but we'll talk about what it is. So, it's an application in which you'll be writing your programs in. They'll contain a source code editor, which is what you'll be working on, a debugger, which will check over your code, and the building tools, and some don't, but what I recommend it does, it'll compile your thing, or your program. Some more modern IDEs have stuff for like hierarchies to show where your file placement is, diagramming, and GUI editors. This course probably won't be covering GUI editors, but just throw it out there. Just want to throw out another note. You can just use a plain old text editor like Notepad, but and then find a standard like compiler. but I wouldn't recommend it. It is such a pain in the ass when you're beginning that if you're new, you'll be confused really quickly. Just trust me on this. Is how I got my start, and it was a mess. Just use an IDE if you're beginning. If you're on your own and you just want to think about how cool you are, then yeah, go ahead. Write it up in Notepad and then just execute it somehow. Yeah, do it. Debugging. And it's basically finding and resolving conflicts and errors throughout any given program. Abstraction. We will talk about this more much later in the course, but just to give you an idea of what it is in terms of a concept of programming, is the idea of, or process of, generalizing something so it can be applied to any given situation versus only using it in a specific problem. In the video previous, you may have seen me talk about, or in my intro to CS, you might have seen me talk about data structures and algorithms, and I brought up the idea that they can be generalized in such a way that they can be applied to like any situation, right? So that's the idea here. This is actually a very fundamental part in particularly object-oriented programming, which will be a definition I'll talk about later, but it's the idea that you want to keep things as general as possible so you can use it anywhere. I know it's kind of repetitive, but it's a very key part. Just recognize the word, kind of recognize what it does, and we'll get into it much later in this course. Syntax, which is the set of rules and symbols that define any given language, versus semantics, which is the meaning of any given language instead of the form, or the syntax. So I'll go into it more in the next slide, but it's basically the idea to say a sentence that is grammatically correct versus like a sentence that actually makes sense. So I don't know, if I were talking like in English, right? I want to say something along the lines of like, I don't know, that apple tastes good. I mean, it's grammatically correct, but if we were to make it, I don't know, maybe a little less formal and say, that apple's good. It's not the most syntactically correct, but semantically, it's the same idea, right? Terrible example. I'm just thinking of something off the top of my head here, but the idea of syntax versus, like, speaking, right? So a compiler is a program that converts the source code, which is written by a human, down into machine code, the ones and zeros, to be read and executed by the machine itself. So paradigms, really important just to get an idea of, and it is the categorical differences between the types of programming languages that exist. So programming paradigms, to give a better definition, it's a way to classify languages based on their individual features. So there's going to be a lot of words thrown your way here in terminology, just roll with it. You don't have to, if you ever see me using them, just, here they are, some definitions as to what they are. You'll also see them a lot online. Really, for an intro course, it's not that necessary to know what they are, but like, just in case you see them, you have an idea. Anyway, so imperative programming languages. This is what the programmer instructs the machine on how to change shape. And then there's two different types, right? So there's procedural, groups of instructions into procedures, and object-oriented, which groups the instructions together based on the state in which they operate. We're not going to worry about procedural. We're going to be worried about object-oriented. For example, C is procedural, not object-oriented, but C++ is object-oriented. Most of the stuff that I'd be talking about on this channel is probably going to be object-oriented. Declarative programming languages, the opposite to imperative. Basically, this is what the programmer is going to declare the properties that they want solved, but not how to do it. You're going to see this in stuff like SQL or some database languages wherein you say what you want, but you're not going to tell it what to do. So the different types of declarative languages is logical, which is the desired result is declared as an answer to some question with a system of facts and rules in place. So set up whatever you want your answer to be and say, do it by just making sure it follows these specific rules. Functional, very hard to program. It's the desired result is declared as the value to a series of functional applications. There is a functional language that we talk about later down the line here, but it's just to show that there is one. We're not going to talk about it like depth. And mathematical languages, stuff like R, is that a desired result is declared as a solution to some optimized problem. I don't really do declarative languages, is what I'm trying to say here. Statically typed programming languages. This is its own thing. It's different from imperative versus declarative. Statically typed is that a variable's type is known at the runtime. The pros of this is that a lot of bugs can be cleared out pretty early because the compiler will catch your error, and it'll compile faster because the native code doesn't have to attempt to figure it out. And so no overhead. Some of the cons can be the errors are kind of confusing, like especially if you're beginning or if you're using your own type, the compiler might throw a fit in terms of trying to convert. It's stuff like that, but we haven't really gotten to what a type is yet, but we'll get there. Dynamically typed programming languages. This is when a variable's type is not known at runtime. So the pros are that it can reduce the clutter of code. It's a lot easier to use variables and manipulate them however you want. But the cons are that, like, I know it's kind of a crap excuse because the cons are like both, oh, it's hard to debug, but at least when you're having like errors with the types and there's some kind of conversion, it can be a little easier than just saying, well, I don't even know what type it is. So yeah, the cons can be really hard to find if you don't even know what the type is. So statically typed languages, you'll see like C++ or like Java. Dynamically typed is going to be stuff like JavaScript, PHP. Basically, if it's going to be used as like a system thing, it's probably going to be statically typed. If it's going to be dynamically typed, it's probably something you're going to see more used on like the web. It's not like a hardline thing between the two different types of languages, but there's a bit of a trend there in terms of commonly used ones. So, on to the next thing. Strongly typed programming languages. This is its own thing separate from static versus dynamic typed. Strongly typed means that a variable's type is defined explicitly. Some of the pros are that the errors are more likely to happen when it's compiling and it's less ambiguous, and some of the cons is that it's a little more intimidating for beginners. Not really that big of a con in all honesty. And weakly typed means that it's a variable's type is implicitly defined. Pros are that it's easier for beginners, cons are that it's like way worse to debug. So strongly typed versus weakly typed very much ties into the previous arguments, right? For whatchamacallit. I don't know why I forgot this. Statically typed versus dynamically typed. They're very much tied together. They're not necessarily one and the same, but they can be. And it's the idea of when you're writing up your variables, right? You want to either state them explicitly, or you can just say, oh, yeah, it's probably this. And again, you'll see it more likely that, it'll be in more web-based languages where it's like weakly typed, or might be more strongly typed in a system one. But again, it's not necessarily the case. Now, I just want to point this out for all these different like typed languages and whatnot, that these are really loose rules because a lot of languages fall under these categories, like a lot. There's very few that are like hard, weakly typed or strongly typed. And this is also the case when you deal with compiling. I just want to throw that out there, that they're really loose. You might see multiple definitions for it. This is just the most basic definition that you can get just to throw your way. Again, you don't necessarily have to think about these very often for intros classes, but it's good to keep in mind. So, compiled programming languages. This means that a program is going to be expressing its directions directly to the targeted machine. Pros are that it's faster because the native code doesn't have to deal with the overhead, and because of that it's also more efficient. But that being said, some of the cons are that the cross-platform support isn't as easy. C++ is something that's like purely compiled, right? Not necessarily interpreted, which will be the next thing, but you might see this in another language, say C#, wherein it's really, really nice and beautiful, but it only really codes nicely on Windows, and that's it. So that's what I mean by cross-platform support not being easy. That and as you'll see in the next one. I'll go into that example, I guess, after I explain it. That'll be easier. Interpreted programming languages. So a program's instructions are read and then executed by another program. This is great for cross-platform support. It is easier to implement, but it's not as fast. Again, rules aren't necessarily strict on this. Now, take Java, for example, language that I'm not the biggest fan of. It is technically more interpreted than it is compiled, but it is very much compiled, and that is because this isn't a Java course, and you'll see how things are compiled at the end, but Java runs through something called the Java Virtual Machine in order for it to be readable by any given platform. It's very versatile in that regard. It's great for scaling, so on and so forth, but it technically means that it's slower than a lot of other languages, than, I don't know, like C++, right? When you're dealing with C++ between platforms, you might have to implement more code just to make sure that it all lines up and that it can work just the same on a Windows computer as it does on Linux. You just have to be careful. You don't necessarily run into it in intro classes, but you can very quickly run into it the more you scale up your program. Just want to throw that out there because, especially if you do something like game development, you're going to run into that like right away, even in something like Unity. So, levels of programming languages. This is now generalized again. There's now precise definitions. So, levels of programming, right? How close a language the programmer is using to the actual machine. So, how close can you get to that direct access, that 1-0 garbage? From low to high, it's generally considered machine code as the absolute lowest, that's the zeros and ones. Assembly language, really hard to read, but it has direct access. Compiled languages, which have direct access to the machine in terms of how it's compiling. And interpreted languages, the most far removed, and they're going to have to go through some kind of application to be compiled. So, machine code. I know I've said it a couple times, but it is the actual ones and zeros programmed directly onto the hardware. Assembly is a symbolic representation of those ones and zeros, and it has direct mapping. So it's not completely one-to-one, but in all intents and purposes, it's basically one-to-one. So, low-level programming languages. They provide little to absolutely no abstraction from a computer's instruction set architecture. You know, the specifics of each individual computer, right? So, pros are that it doesn't need to have an interpreter or compiler to run because it is directly accessing or running from a processor's instructions. It is extremely fast when you're executing. But the cons are that it takes a very long development time. If this were an architecture class, I'd go into the different instruction set architectures, but that's a discussion on its own. It's really cool, blah blah blah. And let's continue. High-level languages are going to isolate the semantics, which, if you remember, is more so how you speak of an architecture from any given language. Pros are that it's way easier to understand, and the development time is much shorter because of that. But the con is it is slower at executing files. So, list of languages from low to high level. Let's start from over here. Oops, sorry. So the lowest level, starting from the bottom up, is going to be machine code, then assembler. The mid-level, which is technically closer to lower, is going to be C, C++, and any system programming language. The mid-high level, which is closer to high level, is going to be stuff like D, Go, and any garbage collection that you deal with. And at a high level, you're going to be dealing with interpretive programming languages, Java, C++, Lisp, declarative programming languages, and SQL. So, in terms of languages themselves, we're just going to go over some really commonly seen ones, and what they are, what they're used to build, some of the advantages and disadvantages. So, let's start with the one that we're actually going to be dealing with in this course. C++ is an object-oriented mid-level language that is strictly compiled. What is it used to build? It's pretty much everything, but to give some big boy ideas, operating systems, henceforth referred to as OS, systems programming, browsers themselves, games, graphics, and database engines are henceforth referred to as DB, cloud and distributed systems, and Arduino. Arduino uses something called C, and C++. It's like a combination of the two. You might see that in some of these, but it just uses C++. Let's just put it that way. Some of the pros of C++ is that it has fantastic library support. It's really fast, it's object-oriented, pointers, which will also be a con, and it has direct memory access. And what the cons for this language are it's machine independent but not platform independent. So you can program this on any machine that you want, but it doesn't necessarily mean that the platform is going to read this exactly the same. So you have to put in some checks and balances when you're going to be porting a C++ program to a different platform. Again, not necessarily at an intro level, but you can run into that really quickly. There's little memory management, mostly because of pointers, and it is syntactically really strict, so that weakly typed stuff is not going to fly, and neither is dynamic. There's no built-in threads, which is something that we won't cover here, but it can be a pain in the ass when you're writing a larger program, and pointers. I'll go into what pointers are in the next video, but let's just say this. They are one of the best features of C++ and the worst. They are very finicky. So, Java. What is Java? Java is an object-oriented high-level language that is compiled. It's also interpreted because of the JVM. So, like I said, not the most clear definitions. It is used to build Android apps, and I don't know how, but it built Minecraft, server-side applications, and Internet of Things applications. Sorry I had to use apps here. I would have liked to have written applications, but kind of running out of space. Anyway, some of the pros is that it is completely platform independent and also machine independent. Therefore, it is multi-threaded. It can create little applets, which are basically little applications you can use on browsers, and it doesn't require preprocessors, unlike C++. We'll go into what preprocessors are, I guess, in the next video. Some of the cons are that it is very strict with its rules and very set with its paradigms. I should also mention that, if you're just used to programming another language, it's very verbose. Like, it takes 5 keywords to write the main method as opposed to 2 like C++. It is slow. It is single inheritance. It has terrible garbage collection, although C++ just really doesn't have any, so I suppose it's a step up. Primitives don't inherit object types. It requires an interpreter, and it consumes a lot more memory. Again, some of these things are not something that you'll have to deal with when you first start, but it can become apparent really quickly. C#. It is object-oriented and high-level language that is compiled and also interpreted. It's used to build Windows applications, Unity games. If you're on Mac, you have to use Xcode. Client-server applications, class libraries, and web services via .NET. Some of the pros. There is lots of support. There are no pointers, yay. Uses just-in-time compiling. There's pretty good garbage collection. It uses events, and you can do a lot with the language even without third-party support or plugins. It's really great. Now, what are some of the cons to this beautiful language? It's pretty much only suited for Windows. It's single inheritance. Server applications must be for Windows. There is no getting around that. It's slow, and for .NET, because it's proprietary, you have to pay for that, which is a shame, but it's a great language. Python. It's a high-level language that allows for both object-oriented and procedural paradigms that is compiled and then interpreted. What is it used to build? It is for machine learning, Raspberry Pi, image processing, math scripts, multimedia, web and test framework, GUI apps, and games. Just a personal side note for Python, I like it, but it's really hard for me to read because I started on C++, and the use of only indentation and just brackets is kind of confusing for me, but that's a me problem, that's not a you problem. Some of the pros are that it's dynamically typed. You can statically type it, you can define stuff and it won't really give you a hassle, but nobody does. It's very forgiving. It's multi-platform. It has great library and framework support, and it is fantastic for hardware projects for Raspberry Pi. Combining Raspberry Pi and Arduino stuff, I'm just going to make a quick side note here, even though it has nothing to do with this programming course. Our Raspberry Pi is more for software-oriented projects, and Arduino is more for hardware-oriented projects. If you want to do some crazy LED setup, you can do it with Raspberry Pi, but it's just better to do it with Arduino. If you're going to make, a little emulator and then you don't shut up about it, Raspberry Pi is your better bet. Anyway, some of the cons are that it's really slow. It can't do anything 3D, really. for games. So you can make cute little 2D games on it and export to the browser, it'll be fine, but no 3D. It is not good with cores and multiprocessors, which is why it's best suited for something like Raspberry Pi. Limitations on database access. I haven't really worked with databases in Python, so I can't speak for that personally. It's not good for mobile development, and it has really poor memory management. Yeah, so another quick side note, whether or not it was obvious, is the higher level you go with your languages, the less memory access you get directly. So a lot of high-level languages are both slow and are not so good memory-wise. Just want to throw that out there. JavaScript. It is an object-oriented high-level scripting language that is interpreted line by line, and then it's compiled. This one's definitely more not object-oriented, interpreting language than it is a compiling language. It is used to build, like, for web development, web and servers, I know it's really repetitive there, games, mobile apps, and smartwatch apps. So this is very good for web development. It's not the only thing it can do, but it's best used for that. The pros are fantastic library support, really fast on the client side, interoperability, which means it's good with multiple platforms, and it's really good for code reuse. Some of the cons. Client-side security is not built in. It can be implemented differently by different browsers on the client side, so whenever you're dealing with web development, you always check on multiple browsers. Yes, even Edge, I'm so sorry. It is single inheritance only, there is no real debugger, and it's not multi-threaded. If you're going to do web development, one of the best places to look for your resources is W3C schools. It is fantastic, but because there's also no debugger, there's not the best place like for documentation libraries. Again, the place I gave you is like the best resource for it, but I just want to throw that out there. Scala. This is like the only functional language I'll be talking about today. So it is a high-level language that is based on object-oriented languages. It allows for functional paradigms and is interpreted, broken down into Java, and then compiled. So it can be used to build data science apps, math scripts, and distributed apps. Functional language is like really good for math, really good, and for databases. Pros are that it works fantastically with Java. No duh. Concise syntax. It's the easiest functional language to learn, but that's not really saying very much. Some of the cons are that there are no primitive types that exist. It could be used for Android, but you absolutely cannot use it for iOS. It won't work anywhere that Java Virtual Machine won't work because it's based on Java. And it shouldn't be used anywhere predictive behavior is needed. This could be said about all functional languages, but just if you're ever going to do that, make sure that you know what you're doing and that you know what you want for your responses. And lastly, we'll go into, in particular, how a C++ program is compiled. So I'm not going to give you a precise definition right now, but what we're going to be talking about is how we're going to compile each and every program, right? So you have your source code, which is indicated by a .cpp in your files, and the header files indicated by .h, right? Put those into the preprocessors. The next step is you want to have all your included files and replace symbols, and then those will all go into your compiler, right? And next we're going to be doing your object code, so .obj or .o, and your static libraries. These are the ones that aren't going to be like changing, right? So your .lib and your .a, those are going to go into your linker. Now that we've finished the build part, now we're going to be going into the run part. So once all of the previous steps have been completed, we start going into the shared library, so like .dll, .so, and the executable, or the .exe. Those go into the loader, which then goes take the input and we put that into the CPU, and then when that's all done, we'll have a completed program. It'll show whatever output that we're supposed to be getting. Now, if we were to change this for, say, another language like, I don't know, Java, right? The whatchamacallit, the JVM is going to be going well, it's going to be, there's no preprocessors in Java, so it's going to be just taking the place right here before it's compiled. That way the machine can read Java, right? So it pretty much reaches the end. So this is what I use for the presentation design. Thank you to SlideGo, Flaticon, and FreePic for these really slick looking templates and icons. And if you guys have any questions, you can obviously find me on YouTube or find me by any of these links. Thank you very much. I'll see you guys next video.